Alright, so in this video I'm going to look at some examples in sine rule, cosine rule over triangle questions, okay? Using these results here, just zoom in for you, there you go. So the sine rule, notice I only just put 2 bits on there, okay? I've not put the equals c over sine c, because when you're using the sine rule, you're only using one bit is equal to another bit, okay? The reason you've got 3 bits is because it applies to all 3 sides, all 3 angles, okay? So I've only just put in those 2 bits there, okay? Don't forget you've got this version as well, the reciprocal of these, when you've got sine A over A. Now before I begin, this is what you want to use for when you're finding a length, this is what you want to use for finding an angle. The reason is because you want the length to be on the numerator, the unknown to be on the numerator if you're finding length, and in this one you want the angle to be on the numerator, okay? You always want your unknown to be on the numerator, okay? Otherwise it's just another 1 or 2 more steps in calculations needed. So first of all, look at a sine rule example, okay? So they don't really come as simpler than that, okay? So you've got a triangle, 70 degrees, 40 degrees, x and 10, and you want to work out what the value of x is, okay? Now, if you've been watching Spider-Man, you notice that Peter Parker has been wearing a t-shirt, okay, that says find x. Well, here it is, okay? Lovely joke, I kind of like that. But of course, you wouldn't get any credit for that in a maths exam, okay? Let's have a look at how you do it. So the sine rule then works like this. You've got the side that you need to find, and then look at the angle opposite that side, which is 40 degrees. So x over sine 40 degrees is equal to, and then another side, 10 over, and then that angle, sine 70 degrees. So you can see what I mean by you only need 2 bits, okay? Because we don't need to know what that and that is in order to work out what this is, okay? Now, the reason I've written like this is because I want to find what x is, so I've made sure it's on the numerator of the fraction, so I'm using this version of it. And also it's traditional to have the unknown term on the left-hand side, okay? Now, you don't need to work out what those are as particular values, okay? They're decimals, of course, but you don't need to work out what they are, okay? So once you've found 10 over sine 70 degrees, that's just a numerical value, okay? And to solve this equation, you just multiply both sides by sine 40 degrees, put that onto the right-hand side, okay? So my first step in working would be this, okay? So 10 over sine 70 degrees, and then you can multiply it by sine 40 degrees, okay? Now you just put all of that into your calculator, it will tell you what it actually is, okay? I'm just checking my calculator in degrees mode, which it is, okay? It says D at the top, which stands for degrees. I do 10 divided by sine 70 degrees. I'm not interested in that number, is it 10.6 something, in case you wanted to know. But I'm going to multiply it by sine 40 degrees, and it gives me an answer. So 6.84 to 3 significant figures, okay? And that's it, okay? Quite often an exam question at GCSE will ask you to round it to 3 significant figures. So there we are. And an A-level or similar course, then 3 significant figures is probably more traditional anyway, okay? That's your first example, okay? And there'll be another one coming up in a minute. Okay, so this is sine rule example number 2, okay? Before I go into example 2, let's talk about why you need to use a sine rule, okay? So here's your trigonometric formulae, okay? We'll notice when using the sine rule, you've got 2 sides and 2 angles in play. When I say in play, I mean you might be given 3 of them and you've got to work out a 4th one, okay? So here you are, you're given 3 here, you've got to work out a 4th, okay? Now with the cosine rule, you have got A, B, C, you've got all 3 sides in play, plus another angle, okay? Now can you notice that doesn't fit that, does it, okay? You don't have all 3 sides in play somewhere, okay? You've got 2 angles, yes, but you don't have all 3. The question doesn't ask us to work out this side is, okay? So that just tells you it's not a cosine rule question, and obviously we're not finding an area here, okay? So the reason you know it's a sine rule question is because you're dealing with 2 sides and 2 angles, okay? Right, let's have a look at it. Now we need to work out this, okay? Now what you'll notice is we'll need to use the sine of this angle here, but we don't have it. That's no problem, okay? Because in a triangle, if you're given 2 of the angles, you can always work out the 3rd one, okay? So it's pretty simple. So we'll do that. 75 plus 55 is 130. Subtract that from 180, that must be 50 degrees. So it's quite simple, okay? And you'll find that there are several questions that require you to work out a simple thing like that before you begin. Okay, so you've got y over sine 50 degrees is equal to, and then this is the other side, we're given 15 over sine, that's the opposite angle, 55 degrees, and there we go. And in terms of rearranging that, I'm going to write it just slightly differently this time, just because I want to show you the quickest way of writing that. So when you bring the sine 50 to that side, I'll just go write it on the numerator like that, 15 sine 50 degrees. It means the same thing, 15 multiplied by sine 50 degrees. It's just that in algebra you'll recall that we don't actually need to write the multiplication symbol for simplification purposes. So I'm just going to write in what that is, type it rather. 15 sine 50 degrees, in case you're wondering what that is, it's 11.49 divided by sine 55 degrees. Okay, but that's the answer we're looking for, 14.0 to 3 significant figures. Okay, and there we go, that's the second example done. Okay, so this is an example in trying to find an angle. Okay, now traditionally we use a Greek letter to represent an angle, and I've used theta. So we're going to find what theta is, and given that that's 60 degrees, and that's 4, and that's 6. So again, it's a sine rule question because we've got two sides and two angles in play, and I'll use that version of it there because we want to have the unknown term on the numerator. Okay, so I'll begin by writing sine theta over, and that's going to be 4, and that's equal to sine 60 degrees, and that's 6 over 6. That's the first step, okay? Now, when you're trying to find an unknown term, you want to get it on its own. You want to isolate it, make it the subject. And so, because we're trying to find theta, the first step we want to do is to multiply both sides by 4. Bring the 4 over to that side. So we have sine theta is equal to, and the simplest way of writing that is 4 sine 60 degrees over 6. Now we can actually work out what that is as a nice exact value, okay? Depending on what stage you're in your mathematical career, you may or may not know what sine 60 degrees is. It's actually root 3 over 2, okay? If you don't know what it is, you just type it in your calculator, okay? And you get, of course, root 3 over 2. But just beware, if you're in year 12 or year 13, I'm expecting you to know that, okay? And then just multiply by 4 and divide by 6, okay? And it gives you root 3 over 3, okay? So root 3 over 3, and that's what sine theta is. Keep that in your calculator display, okay? We're going to work out what theta is now. Now, we need to do the opposite, the inverse operation of sine, okay? We need to find the inverse of sine. And that's either written as arc sine for the inverse operation of sine, or it's written like this, okay? Inverse sine, where you write it like this with a negative one in the top right hand corner. Just be aware it's not a power, it's not sine to the power of -1, because power of -1 means reciprocal. For example, x to the power of -1 means 1 over x, okay? It's the inverse notation. If you've done functions, you'll recall that we write a function like that sometimes. Function of x is equal to something, and the inverse function is written like that, where that's pronounced the inverse of f, okay? So that's what that -1 means. It means the inverse operation, okay? So the inverse sine of root 3 over 3. And what you'll do is you'll use your calculator to actually do that, okay? So if you're using your calculator, use the shift button there. This is my advertising for Casio, okay? Mr. Brown recommends Casio, the #1 calculator for all your scientific and mathematical needs. Okay? I'm just going to do a retake of that, okay? Mr. Brown recommends Casio, the #1 calculator for all your mathematical and scientific needs. I put mathematical first. Right. Anyway, let's go on. So inverse sine of, and it was that, and you get 35.26 degrees. Okay. So theta is 35 point, and it's traditional normally to round these to 3 significant figures. In the GC exam, they often ask 3 significant figures. Even A-level exams probably ask 3 significant figures as well. Okay, and so that is it. Okay. Now, before we go into the next example, I'm going to highlight that the reason I'm giving it as an acute angle is because the angle there in the diagram looks like it's an acute angle. Okay, but there's an example coming up showing you where it could actually be acute or obtuse. Okay. Right. Hope you enjoyed that one. So here's another question where you've got to find an angle, okay, and again I've labelled it theta. But you see this time the angle does not look like it's going to be acute, does it, okay? No, it looks like it's going to be an obtuse angle. So what I'm going to do is I'm going to show you the difference between finding an acute angle and finding an obtuse angle. If you know your angle is going to be acute, you do what you did in the previous example, okay? However, for this one, I'll show you what the method is. First of all, we set it up in the same sort of way. So we'll have sine theta over 20, so that's sine theta over 20, is equal to sine 20 degrees over 8, okay? and then we'll make theta the subject by just putting the 20 over to that side first. 20 sine 20 degrees over 8, and then what we'll do is we'll take the inverse sine of that, okay? So written like this, sine inverse of, and I'm just going to put all of that in brackets, okay? Because you can actually get that far without using a calculator, okay? Just bear in mind, some of you might prefer to write arc sine, that's absolutely fine. By the way, I didn't write it before, so I'll write it now, that's arc sine. So the inverse operation to sine is preceded by the word arc, okay? It's to do with arcs of circles, by the way, but that's another story, okay? And what you do is you work out what the angle theta is. And let's just do that, okay, on our calculators. Right? So what I do is I normally type that out first. So 20 sine 20 degrees divided by 8, okay? And that gives me a numerical value, okay? 0.855, make sure you got that before you do that. And then I'll do the inverse sine of that. So again, you press the shift button and sine, it comes up inverse sine of that answer. And it gives me, and I'll write that down initially, it gives me 58.76 something degrees, okay? But can you see that's not the angle we're looking for, okay? We need an obtuse angle. That gives us an acute angle. Had the triangle been drawn up such that the angle is acute, great, that would be the correct answer. Give it a tick, okay? But we're after an obtuse angle. What do we do for an obtuse angle, okay? What we do is we simply subtract that from 180 degrees. There's a reason coming up in a minute, okay? But what your calculator's actually gone and done is it's effectively worked out what that angle there is, okay? If I draw it out like that, then you can see that's the acute angle, 58.76, and we've got to work out that angle. Hence, you've got to subtract from 180 degrees, okay? So if I just type in 180, subtract that answer, okay, then we get the one we're looking for, 121.23, okay? So I'm going to write that down, 121. Because that's the answer I need, I'm going to write that well, I'll put that to one decimal place now, 4 significant figures, okay? And because I want to leave the answers what theta is, I'm just going to cross that one out, okay? So theta is 121.2 degrees, okay? Now, why does that work? Hold on for just a few minutes while I flip the board over. So that's the correct time to use the word flip. You don't flip a fraction, you flip something like a board over, okay? I don't take the reciprocal of a board. Maybe I'll do it next time. Maybe I'll say, right, I'm going to do the reciprocal of the board. Oh, I'm sorry, did you not understand that? I meant flip the board. Well, when you say flip a fraction in class, say reciprocal, okay? Because that's what you're supposed to say, not flip. Anyway, so that's that off my chest. I feel a lot better now. Let's just draw a sine graph, shall we? Okay, so sorry for the wobbly line, but I'm just trying to hold it steady as well. So that's a sine graph, okay? If you've not seen one of those already, then not much I can do about it, to be honest, but you know, go with it for the time being. That's a sine graph, okay? And the intercepts there are 0, 180 and 360 degrees, okay? Now we're trying to find the inverse sine of that. I can't remember, it was about 0.8 something, wasn't it, okay? And so it was about there. So that was 0.8 something, okay? Because what you're doing when you're trying to find the inverse sine of something is you're looking to see where the sine graph intercepts with whatever the right hand side is, in this case 0.8, okay? And traditionally your calculator likes to give you an answer as close to 0 as possible as an acute angle, and it did, it gave it to us as 58 point something degrees, didn't it? Okay, 58.8 from one decimal place. But can you notice, because the graph intersects here as well, there's going to be another solution by there, and that's the angle we're looking for in this case. Now what we do is we use the symmetry of the graph to try and work out what it is. The symmetry being that it goes up and it comes down at the same rate. So you could put a line of symmetry in by there if you wish. Or you could say that that gap there is exactly the same as that gap there. So you just do 180, subtract that gap, 180, subtract 58.8. And the answer there being 121.2 degrees. Okay, so that's a better explanation than that one there as to why that one is working. Okay. So in short, what you've got to do is just look out for when you need to find an obtuse angle when you're using the sine rule, okay? The first answer you get is not the one you want, just subtract it from 180 degrees and then you'll get the angle that is required, okay? Okay, now we'll do some cosine rule examples, okay? This is a cosine rule because we've got 3 sides and 1 angle in play, all right? So we don't need to know what that angle or that angle is, okay? And so we're not going to use the sine rule, we'll use the cosine rule, because the cosine rule, there we go, we've got 1, 2, 3 sides, and repeat it again, and one angle in play, okay? So this is a cosine rule question. This is about as simple as it gets, okay? Now, we're going to start off the cosine rule like that it says. We're going to start off x squared equals. Now just be careful, we're not going to start it off like that just because that's the unknown term we're trying to find out. We're starting off x squared equals because it is the length that is opposite the angle we're going to use. So notice here the capital C for the angle and the lowercase c for the side. Okay, that means that that must be the side that's opposite the angle that you're using. So because this is the only angle we're given, 50 degrees, we're going to have to use the angle, and then we begin with the side that's opposite it, which is x. Okay, so that's why we start off with x squared. And then it's quite simple. You just do that squared plus that squared, so 4 squared plus 7 squared, and then subtract 2 times that, so 2 times 4 times plus 7, and then cosine 50 degrees, okay? And then that is it, okay? You can simplify it a little bit, so let's just do that. So you've got 16 plus 49, subtract, what's that going to be, 28 times 2, that's 56, cosine 50 degrees. Okay, let's simplify it a little bit more. 49 and 16 is 65, and then subtract 56, cosine 50 degrees. Okay, now be careful because you cannot do 65 subtract 56. Okay, the reason is it's not written in brackets like that. Okay, if it was written in brackets like that, then you do 65 subtract 56, but because the bracket's not there, remember the order of operations. You do multiplication first before you do addition and subtraction, which means you've got to work out that and then do 65 subtract that. Okay. So at that stage, you've simplified as much as you can, and I only use a calculator for the rest of it. So you do 65 subtract 56 cosine 50 degrees, okay, and work out what that is, and that is 29.00 something. Okay. Now you can write that down if you wish. You don't need to, 29.00 something, but just bear in mind that can't possibly be the final answer. Major reason being because that just does not look like it's going to be 29, is it? Because that's 4, that's 7. No, that looks way too big. But mathematically the reason here is because that's what x squared is, okay? So your x squared is equal to this, okay? So therefore x must be square root. A bit like with Pythagoras' theorem, you've got to find the square root to get your final answer. So square root of that, okay, and then that gives me something that's a lot more realistic, 5.39. Let's put it to 3 significant figures, okay. It's actually 5.3855 something, okay. And that is it, okay, that's your simple, basic cosine rule question. Okay, so here's another cosine rule question because we've got 3 sides and 1 angle in play, okay. But this time, notice we're not going to start it with y squared equals because the angle we're using is that one 60 degrees and the side opposite that is 10. Okay, so just remember what I said in the previous example. The angle you're using determines the side that you're going to start it off with. Okay, it's got to be opposite that angle. So we'll start off with 10 squared is equal to, and then we'll have that squared, y squared plus that squared, 7 squared, subtract 2 times y times 7, let's specify that's 2 times 7y, and then cosine 60 degrees. Okay, and then we'll just simplify it a little bit. So that's 100 is equal to y squared plus 49 subtract, and that's going to be 2 times 7 cos 60 degrees. So if you want y, that's 14y. Now cos 60 degrees, that's just a number, a numerical value. You've got to work out what that is. Okay, so put it into a calculator if you want, or if you're in year 12 or 13, I'm kind of expecting you to know that cos 60 degrees is a half, so you can write it 1/2. Okay. So what that means is I can write one more line of simplification, y squared plus 49, and then 14y times a half is just 7y, like that, okay? Now, in case you're wondering how to work this out, we'll just have a look at the equation you've got. It's a quadratic, okay? You've got to work out the value of y from that quadratic equation. And to solve a quadratic, you've got to get all the terms into one side, make it equal to 0, haven't you? So what we'll do is we'll rewrite it like this, y squared, and then subtract 7y, and then we'll bring the 100 over to that side, okay? So 49 subtract 100, so that's negative 51, okay? So that's our equation we've got to solve. Y squared minus 7y minus 51 is equal to 0. Okay, I might need a little bit more space, so I'll just put that down by there and solve that. You can use the quadratic formula. So y equals y the quadratic formula, because that's not going to factorise, and because factors of 51, there aren't many, 17 and 3, there's no way of getting 7 from that, 51 and 1, and complete the square if you want, but that's not an even number, so no. Quadratic formula is probably the quickest way to go. So you have negative b, so 7, and then positive and negative, square root of b squared, which is going to be negative 7 squared, 49, subtract 4ac, so 4 times 1 times negative 51, so that's going to end up being plus 4 times 51, that's going to be 204, isn't it? 204, and then all over 2a, okay, let's just simplify it a bit more, 7, and then that's going to be 49 plus 204, 253. Yeah, it's not a square number, is it? So that's definitely not factorising, that one there. And then we'll work out what those are, okay? Now, I'm going to put these in numerical order. So the first thing I'm going to do is do 7 subtract root 253. And then divide that by 2. And that's going to give me negative 4.45, 3 simple figures. And then the other one, I'm going to do 7 plus root 253 equals, divide that by 2, and that gives me 11.45. Okay, again to 2 decimal places. Why have we ended up with 2 answers? Because it's a quadratic, and usually when you solve a quadratic, like the Sith, there are 2 of them. Okay, and what we've got to do in the context of this question is decide which is the value we want. Okay. We want to work out a length, y, so clearly we do not want to have a negative value because you don't have negative lengths, okay? So the answer to choose is that one there. So you either highlight it, like I've done there, or you cross this one out, or you do both to make it really, really obvious, okay? And 11.45 is the answer we're looking for. But let's just check it, looks reasonable. If that is 7, that is 10, yeah, 11 point something seems kind of reasonable, okay? But can you see it's a very different solution, this question, to the previous example, simply because the side that was opposite that given angle was not the unknown side, so we had to end up doing this. Okay. Hope you enjoyed that example. Okay, here's an example where we've got to find an angle using the cosine rule. So again, because we've got 3 sides and 1 angle in play, you want to use the cosine rule. Okay, and just beware of how you start it off. Okay. So we've got the angle there, we're going to use theta. We look to see what the side is that's opposite that, 7, and that's how we start it off, okay? So 7 squared is equal to, and then that squared plus that squared, 3 squared plus 5 squared, and then subtract 2 times 3 times 5, and then cosine that angle, which I've marked as theta. So that's it. And our goal is to work out what cos theta is. To do that, it's best to simplify this as much as possible before you start rearranging. So on the left, you've got 49, and then on the right, 3 squared is 9, 5 squared is 25, and then 2 times 3 times 5, so that's going to be 30. Cosine 30, cosine, I almost wrote 30 degrees, cosine theta. And let's do it a little bit more, so 49 is equal to 34, subtract 30, cosine theta. Now, do not do 34 subtract 30, as I mentioned in the previous video, because you don't have brackets around that. That is 30 multiplied by this, so you can't isolate the 30. Multiplication has got to be done before you do the additional subtraction, okay? So the thing to do is put 34 onto this side. So 49 subtract 34, so that's going to be 15, okay? 15 is equal to negative 30 cosine theta, okay? Don't forget the negative there, it's important. So next thing to do is just divide by negative 30. So 15 over negative 30, that's negative 1/2. I'm going to write it as cosine theta is equal to negative 1/2. Okay, so you got down to that line. Next, you want to do the inverse cosine. Okay, inverse cosine is written like this. Okay, cosine with the negative 1 there, similar to what I explained with the inverse sine. And you write it as inverse cosine negative 1/2. Or you write it as arc cos. You've got the word arc preceding the cosine, okay? And what you do is you use your calculator to type that in. If you don't know what it is, I mean, some of you will know what that is, okay? If you're year 12 or year 13 possibly. So you do shift cosine like that, okay? And then just type in the negative 1/2, okay, and it gives you your angle, and that turns out to be 120 degrees, okay. You can see it kind of looks like it's going to be an obtuse angle because 3, 5, in order to open up to a 7, it's got to be a fairly wide angle, isn't it? Okay, that is it. Okay, that's your basic cosine rule question. Okay. Okay, here's an example on how to find the area of a triangle using the area is half AB sine C formula. It's very, very simple. Okay, what you need to have is two lengths and the angle between the two lengths. Okay, so what I'm saying to you is in this question, if you had those two lengths and that angle there, you wouldn't be able to do it initially. You'd have to have either those two lengths and that angle, or you'd have to work out that angle somehow. Okay. Anyway, this is your simplest case area of a triangle question. You just put it into the formula: 1/2 times 3 times by 5, and then it's sine the angle in between them, and then you go ahead and work out what it is. Okay. Of course, you need to use your calculator for the vast majority of all this work. So sine 70 degrees multiplied by 3 multiplied by 5 divided by 2, and it gives you 7.05 to 3 significant figures. Okay, and then yeah, that is it. Okay, that's your basic area of a triangle formula question. So this question is slightly more complex in terms of how to find the area of it. Okay, so you want to find the area of this triangle here, but we're given that length, and that angle there. And of course, what we really need is either those two lengths and that angle, or maybe those two lengths and that angle there. Okay, but we haven't been given that. So what makes it more complex is we have to work out something else. Okay. Now, which of these rules are we going to use to work out something else? Either another length or another angle, okay? But can you see, because we've got two sides there and one angle, one potential possibility is to use the cosine rule and to work out this length there, okay? We can do that. Or we can use the sine rule and work out maybe that angle there, okay? I'll use the sine rule, okay? So I'm going to label that angle as theta, and I'm going to work out what that is by doing sine theta over 5 is equal to sine 45 degrees over 7, okay, and then we're going to have sine theta is equal to 5 sine 45 degrees over 7, and then theta is going to be the inverse sine of that. Okay, so let's just work out what that is. So sine 45, okay, it's root 2 over 2 times by 5 divided by 7, okay, it gives me 5 root 2 over 14. Okay, I'm going to type in inverse sine of 5 root 2 over 14, and that gives me an angle. Okay, so inverse sine of that, okay, 30.33 something degrees. Okay, so I now know what that angle there is. Okay, now I'm going to work out this angle next. Okay, let's call that something different. Let's call it angle phi. Sorry if you've not seen that letter before, but that's the angle I'm going to use for. Okay, and it's quite simple. What I'm going to do is I'm going to do 180, subtract that, and gets me that angle there, doesn't it? So 180, subtract that, and then subtract 45. So that means this angle up here, phi, is 104.66 something degrees. Okay, and now I can do it. I can work out the area of the triangle because I've got two lengths and an angle in between. Okay, so I'm going to write up area equals 1/2 times 5 times 7, 5 times by 7, and then sine that angle, sine 104.66 degrees. Okay, just before I work that out, just notice I'm using the exact values in each case. The dot 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 there means I'm not rounding it, I'm using the exact value, because if you start rounding too early, your final answer is not going to be as accurate as you might want it. Okay, so I'm going to type in sine of that first of all, and those of you who've not noticed, I've not reset my calculator at one single stage. If you want to just rewind the video and check it, okay, but I've not reset my calculator at any stage because I want to use the same calculation again. So I've just done the sine of that, and I'm going to times it by 5 times 7 divided by 2, it gives me an answer 16.9. And I'm going to add 3 significant figures. Okay, that's going to be square units. Okay, so that's that one. Okay. Okay, same example, just slightly different method. Now, if you recall, I did say that one method was to use the cosine rule to work out this length here and then do it. Let's just see how that goes. Okay, so I'm going to label that x and then use the cosine rule formula to do it. So here's the angle we've got to use, 45 degrees. That one is the opposite length, so we're going to have to start it off 7 squared. And then 7 squared equals 5 squared plus x squared, subtract 2 times 5 times by x, cosine that angle there, 45 degrees. Okay. And you see it's already going to be a little bit more challenging for us because it's going to be a quadratic. Okay. That's why I went for the sine rule, okay, because I knew it was going to be easier. Anyway, let's follow this through. So that would be 49 is equal to 25 plus x squared. And then let's work out what this is, shall we? So cos 45 degrees is root 2 over 2, okay? As I type it in now, you can check that with me. And then when you multiply it by 2 times 5, okay, we get 5 root 2. So that's going to be subtract 5 root 2x, okay? And because it's a quadratic, we're going to have to get all the terms to one side. So x squared subtract 5 root 2x, and then we want to have that onto that side, so that's going to be subtract 24 is equal to 0 if I put that onto that side, okay? And then you're going to use the cosine, so the quadratic formula to work that out, okay? So that's going to be 5 root 2, positive, negative, and then b squared, so that's squared, so that's going to be 25 times by 2, that's 50. Subtract 4ac, so subtract 4 times 1 times negative, 24, that's going to be plus, that's going to be 96, okay, all over 2. And then let's just get rid of that, okay, down with that. And that will simplify a little bit to 5 root 2, and then positive and negative, that's going to be square root of 146 all over 2. And work out what the value of x actually is. Now you can check it if you want, but one of those answers will be negative. Let's just check that. So 5 root 2, subtract root 146. Okay, yeah, that's going to be negative divided by 2. So that's negative 2.50 something. I'll cross it out straight away because that's not what we want. We want a positive answer. Okay, and the other answer, the positive ones, would be 5 root 2 plus root 146, and then divide that by 2, and that's looking much better. Well, not as a value, it's looking a bit nasty, but that's a positive answer, 9.577 something, okay? So that's that there, okay? And then we can apply the area of the triangle formula, so that's going to be a half times by that 9.57 ... multiplied by that 5, and then sine 45 degrees, because we're using that length this time, and the sine of the angle in between them, okay? Let's work out what that is. So I've got the 9.57 already in my calculator, times that by 5, divided by 2, and then multiply by the sine of 45 degrees, and we get 16.9. Again, to 3 significant figures, okay, which is the exact same answer we had last time, okay. And of course, yeah, it's going to work because even though it's a different method, it's still a correct way around, okay. So just to sum up, the sine rule version, the one I used first, was the preferred method because it's a little bit simpler, but yeah, if you went down the cosine rule route, then you'd still get the right answer, okay. I'm hoping you found that useful, all right. That's it for now. I don't need to do any more examples because I've covered all of them, sine rule, cosine rule, area of a triangle. It's now up to you to just work through some more questions, okay? The more questions you work through, the better at it you're going to be. I hope they go well for you, okay? But thanks for watching. Take it easy.